One amazing feature of Rust is the concept of multiple entry points. And this is a very powerful feature that you can implement immediately in Rust. And the way it works is that you can write code once, have some shared structure, for example, a library or a database or some kind of core logic, and then start with the development as a CLI. Then later, you can expand out to a microservice, potentially also another service like maybe a web assembly type product or a GUI. But you have this one entry point that really helped you build that feedback loop of getting things to work. And this is something that is easy with Cargo. I'm going to talk about how I do it myself and why some of the logistics are pretty simple when you're developing multiple entry points in a Rust project. So the idea here is that why would you do this? So in terms of core architectural benefits, you write the code once and you use it everywhere. So the same business logic is going to power a CLI tool, a website, maybe cloud functions, and the CLI is so quick to iterate on, and that's why you want to start with the CLI. Because Rust has safety guarantees, it's going to prevent crashes and security issues across all these different resources. And then because you have strong typing, your API is going to be consistent, whether it's a command line, a web application, or a cloud service. And this is really, again, a benefit of a modern compiled language. Because you can use async programming, the model is going to work across all the environments, and you're going to be able to write efficient code once and deploy anywhere. Now, in terms of the CLI entry point advantage, the idea here is that you can build things very, very quickly because you have that feedback loop. And in many cases, the CLI is the fastest possible user interface. The CLI is a user interface. It's just a different terminal-based user interface. You can get the logic working. You can do things completely offline, local environment. You can have direct access to local files, devices, system resources. You can automate tasks. Once you get this thing working, then you also can build out extensive command line options. Now, once you've got things stabilized, the next step would be to think about a web API. So could you do automatic checking to make sure that whatever you did with the CLI can also have an API contract? Also, you could have error handling that is going to work the same in the web as it does in the CLI. And then you could have data conversion so that the same thing is going to be consistent. Again, like if you have a JSON payload, it would look the same as a payload that is accepted from a CLI. And really in a nutshell here, it is going to enhance your ability to create these web APIs. And because many people are using generative AI, because you have this really nice structure, it's going to be trivial to extend it to a different service. Now, you could also do things like Lambda runtimes, which allow you to do, optimize ARM code. You can have a no saved state philosophy as well, where you're going to use, Rust memory management philosophy with ownership. You can do event-driven programming. So there's lots of things that are really interesting about taking a CLI that also works with a Lambda, because again, the logic is already flushed out, and potentially you can have a template that you feed into a coding system that helps you extend it to another endpoint. And then in the case of shared code, because you have been able to design things with Cargo where you have multiple entry points, the Cargo ecosystem already expects this. And so it's very trivial to have different entry points. And from a DevOps perspective, what's really nice about it is the same core code is deployed to multiple environments, right? You build once, deploy many. The infrastructure as code is going to stay the same. The tests are going to stay the same. The dependencies are going to stay the same. And so you remove that issue of it works on my machine. And then in terms of the performance optimization, Rust is going to figure out the fastest code path at compile time, not at runtime. You have memory layout optimizations, processor-specific improvements. You have fine tuning as well that you can do. You can have a smaller program size through shared components, and then the security as well, because you have memory safety, security audits, etc. So there's a lot to like about, essentially going past this idea of using scripting languages for prototyping. Hey, I want to talk to my compiled code with a CLI, or I'm going to wrap it up in a web interface, is why with Cargo, you can have multiple entry points and solve the same problem. So I think this is going to be an emerging trend as people use more and more generative AI tools to help them program, is that you build the core logic and then you also say, look, I want to extend it to Lambda, or I want to extend it to a microservice, or I want to extend it to a GUI or a WebAssembly project. And it becomes trivial because you've already got this really awesome CLI core that is going to be the basis for your extension.